Hello everyone. So it's Fred, and this is my app that I built for the project. And I'm going to give you an overview before I go to the details of it. And it's an AI-powered application. And when we talk of AI is when we try to train machines to mimic human beings. Like for example, natural language, like for example, vision. So for this scenario, I tried to uh, to 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 incorporate vision, that is object detection, that tries to imitate human vision. And what I'm doing here is that I researched and found out there's a big problem here we have in Uganda, most especially in rural areas. There is a slow process in diagnosing, most especially malaria, which is a simple disease but is very fatal when it's not when the disease is not uh, detected or identified early enough so that the patient can receive early treatment. When it's delayed, it's very fatal and it's very deadly. So my app helps streamline this process and helps the health workers detect and go through this process as fast as possible. Uh, it's an app it's a model that I built that is very accurate, fast, that can help. It's not prone to human error, so it's better, and it helps a lot. For example, in human rural areas, the there might there might be low or no health personnel that can help with this. So let me take you right to let me go through the overview of this. So I'll go and adjust the confidence threshold here. So a user can go and browse these microscopic images, malaria blood smears online, but I've already downloaded mine in the download, so I can go and find it here. Just a moment. It's right here, I downloaded it. So I'll tap on it, open it, and it will be downloaded on the app here, on the sidebar. As you can see, it's there. These are microscopic images that are taken from the microscope. These are got through smartphones. I won't go to the details of that. So as you can see, a detect button pops up right away here. User can go ahead and click that. Let's give it a few minutes, not minutes, seconds actually. It will have detected uh, parasites in this blood. As you can see, there are quite a lot of trophozoites, which means that it's quite this patient needs immediate medical attention. When we go to the summary here, it should tells us that there are 10 detected parasites, right? So without wasting time, let's get uh, to what is important here. Now, so this is where I got my data set from Cargo, and there's quite a lot to go through here. Just know that this way the data set that I got is quite authenticated. It's real. It's not faked. So, and when you come here, this is where I coded everything from Google Colab. This is because it gives us free GPUs that is able to train these models. These models can't train on regular CPUs. It needs really a strong, needs a machine. It needs kind of those resources are needed, like GPUs and storage, because these files are very heavy and need all that. So this is me accessing the files, downloaded them there, and imported the necessary libraries I needed there. I'll go through the details. So the next part here is I'm trying to augment these images, augmenting them such that the model doesn't over generalize this and cram these images and how they look, the shape and all that. So we try to augment such that the model can generalize them very well and become a robust model. So from all this code to down, this is me trying to get the quality data that I need for training the model. And as you slope down, this means trying to sieve and select what is best from the images such that the model can train from the best. Yeah, this is all the code for augmenting, pre-processing. I'll not go through all those details. And then this is where I get the model, download it. That is a YOLO-V small model. Then I've calculated what I need here. I need 50 epochs, patient 300 image size. It also matters the image size, the quality of the image. It helps the model train better. And then the batch to reduce on straining the resources that are free that I'm using there. So as you slope down here, yeah, this is a conversion matrix. When you look through the conversion matrix, you can see that there's a lot of misclassification here. The model is not perfect. It needs more. There's need to. It's doing good, but there's a lot of work that needs to be done here. Yeah, so you can see all those details, the artifacts, all those. I'll be sending them right through. So you can see that on the validation set, it's kind of doing quite good work here. When you see on the white blood cells, it's kind of giving 80% confidence, right? So it's doing poorly on the trophocytes. Reason could be because it's very tiny. These are tiny objects that need to be thoroughly pre-processed for the model to generalize them very well. Yeah, so that is it. The models, I trained the model and the weights I exported them to the drive. This is where the weights are, the model that was trained. It's called the best. I exported it and right is that model was hosted on GitHub. Yeah, it was hosted on GitHub. So this is what I did. I used Streamlit for building the user interface and then hosted the model on GitHub and then also used Streamlit for backend services. So Streamlit is just used for prototyping. It helps with prototyping. It helps to come up with something that the user can work up as you iterate and make it more better. So I wanted to show you my code through the Visual Studio Code, but it's kind of taking too long. So let's just go through it from the GitHub. I'll send all this which is spread. So this is the main component here. The app.py is where most of the UI, where the UI happens, the upload, the drawing of the bounding boxes, and all that. Yeah. So I think I'll end here because of time. I thank you very much for listening. Have a good day.